Clara, the red graph, and Paula, the blue graph, are driving two separate cars to New York. They begin the trip with full tanks of gas. The amount of gas in gallons that remains in each car depends on the number of miles driven, as shown on the right. After how many miles will the tank contain the same amount of gas? If the number of miles driven is more than this, which car will have more gas in its tank? So let's start by just looking at this chart and trying to get a good understanding of it. Clara is the red graph, which is this one right here. And at the beginning of the trip, well, let's look at the scales. This vertical scale is gallons of gas in the tank, and this horizontal scale is miles driven. So the line is going to give me the amount of gas in the tank, the amount of gas in the tank versus how many miles driven. So at the very beginning, we can see that Paula is starting with 60 gallons of gas in her tank, and Clara is starting with maybe looks like 55, 10, 20, 30, 40, 50. Yeah, it looks like about 55 gallons in her tank. So Paula begins with more gas than Clara. At the end, it looks like Paula can't drive quite as far than Clara. So maybe her car isn't a very efficient car and burns gas faster than Clara's. So let's read the question. After how many miles will the tanks contain the same amount of gas? So this line, this blue line, is the amount of gas in Paula's tank. This red line is the amount of gas in Clara's tank. The two lines cross each other at this point. So at this point, they have the same amount of gas in their tank. So they have the same amount of gas right here, which is 250 miles. So when they've driven 250 miles, they'll have the same amount of gas. If the number of miles driven is more than this, so here's 250 right here. If the number of miles driven is more than this, which car will have more gas in the tank? So we can see that the red line is higher than the blue line for the rest of the trip. So that means that Clara will have more gas in the tank after they have both driven 250 miles. So Clara has more gas. After 250 miles. A farmer has 1,756 feet of fencing available to enclose a rectangular area bordering on a river. No fencing is required along the river. Let X represent the length of the side of the rectangular enclosure that is perpendicular to the river. Complete parts A through C. So in part A, what we want to do is we want to create a function that represents the area. So in part A, we want to find the area function as a function of x. In our picture, you can see we have the river here. No fencing is required along the river. And we've labeled this side that is perpendicular to the river as x. Because this is a rectangle, we know that this side will also be x. And we want to label this side that is running parallel to the river. And we know how to label that because we have 1,756 feet of fencing. So the rest of the fencing is going to go along this portion. X of it will go along this, and X of it will go along this. The rest of it will go along this one parallel. So that's going to be 1,756 minus 2x. Now, area of a rectangle, if you have a rectangle and you're trying to calculate area, that's going to be the width of the rectangle times the length. So area is length times width, or width times length. So for our area function, we want to use x times 1,756 minus 2x. This gives me a quadratic function, 1,756x minus 2x squared. So we have a quadratic function. In part B, what we want to do is maximize the area. We want to find the dimensions that will maximize the area of our rectangle. We want to have the largest area inside of this rectangular enclosure. Now we have a quadratic function, and we want to find the maximum area. A quadratic function with a negative leading coefficient will have a graph that's a parabola facing down. And so this is our area, and that maximum area will occur at the vertex. So we can answer this question about maximizing the area if we find the vertex of our quadratic. Now, there is a formula for vertex. The vertex is an ordered pair. We usually label it with HK. And the formula for H is negative B over 2A. So what I mean by that is that if your quadratic function is written as ax squared plus bx plus c, then you can use a, the coefficient from the squared term in the formula, and b, the coefficient from the x term in the formula, to get the x coordinate of the vertex. So that will give negative 1,756, that's our value of b. B is the coefficient of the x term. And then negative 2 is a, the coefficient of the squared term. We'll do 2 times negative 2 to get 1,756 over negative 4. And let's divide that out. 1,756 divided by 4 is 439, and that's a positive value. So that gives me, for this figure, that gives me this side here, 439. We want to find the side parallel to the river as well. We want to find this side, and that's going to be 1,756 minus 2 times 439. So 2 times 439 is 878, and we still need to do 1,756 minus that. You'll have to excuse me, I don't know how to use this calculator, so I have to do it one more time. 1,756 minus 878 is 878. So the length along the river is 878. In this problem, we're using feet. So this is feet, and this is feet. Our dimensions are 439 feet by 878 feet. And our final part is to find the area at maximum area. And there are a couple different ways you can do it. You can substitute this value of 439 into the area function, or because you have the dimensions of the rectangle, you could just multiply length times width. So you could do 439 times 878 to get 385,442 square feet as that area that is the maximum. On this question, we're given the function f of x equals negative x plus 1 squared minus 1. This is a quadratic function in vertex form. And it's in vertex form because it's fitting this format here, a times x minus h squared plus k. Now, there are 3 things that I'd like to know about this particular quadratic function. The first thing I want to know is, what is the vertex? So in order to know the vertex, you have to know that this hk represents the coordinates of the vertex. So the ordered pair hk is the vertex. We can match those positions up in our problem. And the only thing is that you notice you have a minus sign in the vertex formula, but we don't have a minus sign in our equation. Now, every addition can be written as subtraction if you subtract the opposite. So you turn that plus into a double negative, and that's going to make our x coordinate a negative. So we have a vertex of negative 1, negative 1 for this problem. The next thing I want to know is, does the graph of this open up or down? Now, the graph of a quadratic function will be a parabola that either opens up or down. And we can determine if it opens up or down based on the value of a. Anytime a is positive, the parabola will open up, and anytime a is negative, it will open down. You can see that our value of a is negative 1, and so since a is negative 1, which is negative, we know that the parabola opens down. And the final thing that I want to know about this function is the axis of symmetry. Now, as I said a moment ago, the graph of a quadratic is a parabola, and these parabolas will be symmetric around the vertex. So let me mark where the vertex is. And if we draw a vertical line going through the vertex, what you'll see is a mirror on either side of that vertical line. You'll see a mirror image on either side. And so we call that vertical line the axis of symmetry because on either side of that line it creates that symmetry or that mirror. So we're going to be able to find the axis of symmetry using the vertex, and since it's a vertical line, we're going to use the x-coordinate of the vertex. And we have the axis of symmetry being the vertical line x equals -1. Thank you for checking out my videos. Have a great day.